Namaste, dear children. Welcome to Deeksha online bridge course. Subject is physics, and today's topic of discussion is Newton's laws of motion. What is that we are going to discuss in today's session? We will start off with the Newton's first law of motion, and this law is due to a property called as inertia. We will discuss about inertia. We'll understand the meaning of force. What do you mean by momentum? Then we will move on to understanding Newton's second law of motion, and then at last the very familiar Newton's third law of motion. These are the topics that we are going to discuss in today's session. We all would have gone for a long drive, or we would have traveled in the bus. During that journey, have you ever experienced this? Suddenly, when the driver applies the brake, we tend to fall down, or the bus suddenly starts moving, we are pushed back. At the same time, when a cleaner or the service boy in the bus gets down a moving bus, he runs for few steps, then comes to rest. Better you don't try it. Why do you think this happens? It is explained by Newton's first law. It states that every body continues to remain in the state of rest or in the state of uniform motion along a straight line unless compelled by an external force to change that state. I repeat, every body continues to remain in the state of rest or in the state of uniform motion along a straight line unless it is compelled by an external force to change the state. For example, if a body is at rest, it won't move, it will remain in the state of rest until somebody exerts a force. The same way, a body in motion will continue its uniform motion. That means the speed, the magnitude of the velocity does not change until an external force acts. Suppose you are going for a long drive, there is a straight, flat road. Even if you don't press the accelerator, the vehicle keeps moving with almost the constant speed in the absence of friction. And in the same way, the body will continue to move in a straight line. You observe while riding a bike. Suppose you want to negotiate a curve or take a turn, you have to apply the force on the handle, turn it, then only you can change the direction. Until and unless you exert the force, the direction also doesn't change. So, the Newton's first law states that an object will continue to remain in the state of rest or in the state of uniform motion along a straight line until and unless it experiences an external force. Now, the cause for this is a basic property of matter which is called as inertia. Inertia makes the body to remain at rest or continue its uniform motion along a straight line. What is this inertia? Inertia is a property of a body. It is not a property of an external agency, it is the property of that particular body, by virtue of which the body is unable to change its state. Unable to change its state means if it is at rest, it will remain at rest. If it is in motion, will continue its motion. So that state of rest or motion cannot be changed by itself when there is no external force acting on it. So What do you mean by inertia? Inertia is the property of a body by virtue of which the body is unable to change its shape, change its state by itself in the absence of an external force. There are three types of inertia: inertia of rest, inertia of motion, inertia of direction. Suppose in this case we have a coin placed on a sheet of paper. When I push the paper, the coin will fall into the glass. The coin is in the state of rest. The force is acting on the paper, not on the coin. So the paper will experience an external force and the paper will move off. But the coin did not experience any force, it will remain in the state of rest. This ability of the coin to remain at rest is called as inertia of rest. Same way, when you are traveling, you are moving in this particular direction. Due to a signal, if the driver applies the brake, you tend to fall forward. This is because you are in the inertia of motion. The tendency of a body to continue to move further in the absence of external force is called as inertia of motion. Same way, if you see this lorry, it has to negotiate a curve. While coming here, if the driver doesn't rotate the steering, the lorry would continue to move straight like this. It wouldn't change the direction by itself. This property of a body, by virtue of which it doesn't change the direction, is called as inertia of direction. Now, as we are speaking in the inertia, we are speaking that an external force is required to change the state of the body, to change it from rest or to change its state of motion, either increase the speed or decrease the speed, change the direction. There is an external force required. What is this external force? It is an agency which tends to change the state of rest of a body or the state of uniform motion of a body along a straight line. A force is an external agency that changes or tends to change the state of rest of a body or the state of uniform motion along a straight line. Suppose there is a body which is at rest. In order to change its state from rest to motion or move it from one place to the other, we need to apply an external force. This agency, which causes a change in the rest state of the body, is called as force. In the same way, when a body is in motion, it will have velocity. Velocity means it has magnitude and the direction. An external agency which will either change the magnitude or change the direction of the body or both of them will lead to a change in the velocity. It will change the state of uniform motion of a body. That agency will be called as force. It is defined as force equal to mass into acceleration. If you remember, when we discussed vectors, we discussed about multiplication of a scalar quantity with a vector quantity. Here mass is a scalar, acceleration is a vector, force is given by the product of mass and acceleration. It is a vector quantity. Whatever is the direction of acceleration, same will be the direction of force. Suppose there is a vehicle moving in this direction with a velocity equal to u. If the acceleration happens in this direction and the velocity increases to v and the mass of the body is equal to m. So you observe the velocity is increasing, that means the acceleration is in this direction. For this to happen, the force should act in this particular direction. Suppose if the body was moving with a velocity equal to u and the mass of the body equal to m, over a period of time, the velocity decreases and the velocity becomes equal to 0. That means there is a retardation in the body or the acceleration is acting in the opposite direction. Then the force acting will be in the direction of acceleration. So this unit will be kg meter per second square. All this put together collectively, the SI unit is named after the scientist Sir Isaac Newton as Newton. When you write the entire name, though it is the name of the scientist, write it in small letters. When you write the symbol, any unit named after a scientist, the symbol should be written in capitals. The CGS unit of force will be dyne. Dyne is the CGS unit of force. And moving on, there are two types of forces. One is called as the contact force. The contact force comes into picture when there is a physical contact between the two bodies which are experiencing the force. Say, for example, when you are pushing the car, you can't stand somewhere here and do some mantra and push the car. You have to actually have a physical contact with the car. So, for a contact force, it is the force between two interacting bodies which are physically in contact. Like somebody slaps you, he can't stand 1 kilometer away from you and slap. There should be a contact between his hand and your cheek. Then only the force will act. Uh, these forces are called as contact forces. The next one is non contact force. Let's say, for example, here, any object which is falling under the gravity, Earth is pulling with a gravitational force. In this case, there is no contact between the Earth and the object. They are called as non contact forces. Let's say you would have studied about Coulomb's law. According to Coulomb's law, if there are two charges Q1 and Q2, they are separated by some distance. Now, they both experience a force due to the property of charge. Now, this force doesn't happen that the Q1 will come and touch Q2, Q2 will come and touch Q1. No, they never come into contact. That is why they are called as non contact forces. If two interacting bodies are not physically in contact with each other, but even then they are able to exert the force on each other, they are called as non contact forces. Gravitational force, electrostatic force, you can take the magnetic force. If there is a magnet, this is the north pole, this is the south pole, and I have a piece of iron. Now the magnet doesn't go here, hold the iron and pull it. There is still a force of attraction without both of them being in contact with each other. Such forces are called as non contact forces. Now we will go to the next concept called as momentum. Momentum is defined as the product of the mass of the body and its velocity. The product of the mass of the body and its velocity is defined as momentum. It is given by P equal to mass into velocity, where m is the mass, v is the velocity. Again, if you observe, velocity is a vector quantity, therefore momentum is also a vector quantity, mass into velocity. Whatever is the direction of velocity will be the direction of the momentum. So, momentum is a vector quantity, its direction is along the direction of velocity. The unit for momentum is kg meter per second. Mass is in kilogram, velocity is in meter per second. Suppose there is a ball. The ball has a mass equal to m. It is moving with a velocity v in this direction. Then the product of this mass and velocity is called as linear momentum. Because the body is having velocity in this direction, the momentum also will be in the same direction, along the direction of velocity. Why is this momentum so very important? You remember we discussed about inertia. There are three types of inertia: inertia of rest, inertia of speed, or inertia of direction. The mass of the body will determine inertia of rest. The momentum of the body will define inertia of motion. Suppose a body has very high mass. It has more tendency to remain at rest. It has more inertia of rest. For example, when you are seated in a class, to lift a book on the desk, it is very easy. A small force is required to change the state of rest of the book. It has less inertia. It has less tendency to remain in the state of rest. But to lift the desk, you need more force. The mass of the desk is more. Its ability to remain in the state of rest is more. It has more inertia of rest. Now coming to inertia of motion, both direction as well as speed, it is defined by momentum. Suppose you have a bus heavily loaded. When the bus is heavily loaded, the mass is more. Its ability to continue in motion will be more. That is why it is relatively easy to bring a cycle to rest, but not a lorry to rest. Mass are different. Then, velocity. It is easy to bring a cycle which is moving slowly to rest, but it is tough to bring a bicycle moving at a very high speed to rest. Even on applying the brakes, it will jerk and skid for some distance. So, higher the velocity, it will have more ability to continue in the state of motion. So, both mass and velocity together define inertia of motion. This term is called as linear momentum, or in simple, momentum. Now, you would have heard these terms. When a bullet is fired, the gun will recoil after the bullet has been fired. That means when you press the trigger, the bullet moves forward, the gun is pushed back. This is called as recoil of the gun. I repeat, when you press the trigger and the bullet rushes out, during this moment, the gun is pushed back. This pushing back of the gun is called as recoil. When somebody jumps down the boat, Let's say this gentleman is jumping from one boat to the other boat. So he moves forward. During this process, the boat is pushed backwards. Why do you think this happens? This is due to the principle of conservation of linear momentum. The principle of conservation of momentum states if there is no net force acting on the body, on two interacting bodies, then their total momentum remains conserved. When there is no external force acting on two interacting bodies, then their total momentum remains conserved. This is called as the law of conservation of linear momentum. Let me consider two objects A and B. A is having a mass ma moving with a velocity vai. I indicates initial. B is moving with vbi. I indicates initial speed or velocity. Now you observe they both are moving in the opposite direction. Both of them put together, the initial momentum is equal to mass of A, velocity of A initial plus mass of B, velocity of B initial. This is the total momentum of both of them put together before they collide. After collision, they both go and collide with each other. They exchange some force due to which they tend to move either in the opposite direction or the same direction. I don't know, but their velocities would have changed. A starts moving with velocity of A final, velocity of B final. The new momentum after the collision will be equal to MA VA final plus MB VB final. This is the total momentum after collision. This is the total momentum before collision. You observe in this case, there was no force from an external source. They are colliding, they are experiencing the force only between them. There is no collision, there is no external agency which is exerting the force. Then in that case, the initial momentum will be equal to the final momentum. This is called as the law of conservation of linear momentum. I repeat once again, if there is no net force acting on the body, then the total momentum of the system of colliding bodies will remain conserved. So let me take, for example, there is a ball of mass m1 or ma as per the previous problem is moving in this direction with an initial velocity equal to u. There is u1, let me say. There is another body of mass mb. This is moving in the opposite direction with a velocity equal to u2. They both collide with each other, but the force is not acting from any external source. The force is between only both of them. Then the initial momentum Pi will be MAU1 plus MAU2. After collision, let us assume A starts moving in this direction, B starts moving in this direction with velocity v2 and v1. Then the final momentum will be equal to ma v1 plus MB V2. So I made a mistake here. It should have been MB. So you understand that momentum is a vector quantity. You need to add them vectorially. If you remember, we had triangle law and parallelogram law of vectors. You need to use one of those two laws to add them. Don't blindly add whatever value is here, whatever value is here. Don't add them blindly. So, in the first case here, in the initial momentum case, if I choose this as the positive x-axis, u1 is in this direction. I have to take it as positive. u2 is in this direction, so I have to take it as negative. When I am adding them vectorially, then the theta is equal to 180, cos 180 equal to -1. Therefore, your resultant formula, the magnitude of r square will be equal to a square plus b square plus 2ab into cos 180 is -1. This is a minus b the whole square. So your magnitude of the resultant will be a minus b. So your initial momentum should be given by this formula. Pi magnitude will be equal to m1 u1 minus m2 u2. Same way, after collision, V1 will be taken negative, V2 will be taken positive. Final momentum will be rewritten as M1 V1 with a negative sign plus M2 U2. Here, I have also considered the direction. Here you write only the magnitude, the minus sign will show me the direction. This is law of conservation of linear momentum. Now something to think about. Why does a cricket player move his hand down with the ball while catching it? And why does a high jump athlete fall on a sand bed or a cushion, not directly on the floor? You observe the player catches the ball, afterwards he moves the hand slightly down. Why does he do that? And a high jump athlete doesn't fall directly on the floor, there is a good amount of cushion available. Like when you sit, you are comfortable on a sofa rather than a flat, hard surface. This is due to a concept called as impulse. Impulse is due to a large force acting for a short interval of time. A large force acting for a short interval of time is called as impulse or impulsive force. Suppose this gentleman or a lady falls from such a height directly on the ground. There is a large force acting on the ground for a short interval of time. Its impact is very, very high. That is why the player will catch the ball and drag the hand back. So he is going to take some time for the force to act on him. But when you are going to hammer a nail, you are going to exert a force on it. You are going to exert a large force in one shot bang. The time is very, very less. Such large forces acting for a short interval of time gives rise to impulse. It is obtained by finding the change in the momentum of the body. You see, the force can be written as mass into V minus U by T on opening the bracket. This will be mv minus mu by t. But because time is very, very small, if I put it as 0, anything by 0 becomes infinity. That is why I take time to the left hand side and define mv minus m into u. This product or this difference in the momentum gives you impulse. So if you observe, I am taking the difference here. The unit of impulse will be same as the unit of momentum. So the unit of impulse will be kg meter per second. Suppose you are studying about dimensions. In first year, the very second chapter will be units and measurements. In that topic, if they ask, give example of two or more physical quantities having the same unit or same dimension. You can take example of momentum and impulse. Remember, impulse is only the change in momentum. If you remember in differentiation, we studied about the small change, then it is represented by delta P or sometimes as dP as well. This is impulse. Now let us move on to Newton's second law of motion. The Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the external force acting on the body, and the change in the momentum takes place in the direction of the applied force. I repeat, the rate of change of momentum of a body is directly proportional to the external force applied on it, and the change in the momentum takes place in the direction of the force. Let's say, for example, there is a body of mass m. It is moving with a velocity equal to u. On such a body, I will exert a force F for a time equal to t seconds. When the force F vector acts in this direction for a time equal to t seconds, the velocity of the body, which was u after t seconds, would have become equal to v. Now, the change in the momentum delta P is equal to mv minus mu. This gives change in momentum. But for this momentum to change, it had taken some time. That rate of change of momentum is given by is directly proportional to the force. Force is equal to change in momentum divided by time taken. If the time for which the force acts is also represented as delta t, then it is delta p by delta t or dp by dt. If you remember, we measured some of the rate measures in differentiation. So if you get an equation for momentum, differentiate it with respect to time, you are going to get the force acting on the body. The force, therefore, can be represented either by this formula. mv is the final momentum, mu is the initial momentum. So the numerator will be change in momentum and divided by t will give you the force. So mv minus mu can also be rewritten as dp. So therefore force can be rewritten as dp by dt. Now let us understand three different cases. Case number one. There is an object of mass m. It is moving with an initial velocity equal to u. An external force F acts on the body for a time equal to t seconds. After t seconds, the velocity of the body becomes equal to v. Therefore, when an external force acted on the body, the mass did not change, mass was a constant. Therefore, from Newton's second law, F can be written as F is equal to dp by dt. dp is the change in the momentum. This will be equal to mv minus mu divided by t. So here m and m are constant. The mass did not change. So I can write it as m into v minus u by t. Velocity has changed. So this is nothing but rate of change of velocity. M into dv by dt. What is dv by dt? Acceleration. Therefore, force can be written as ma. Here, in this case, only the velocity of the body is changing. dv by dt. The mass of the body remains a constant. Now, let me take a second case. There is a truck. The truck is carrying some load. Let the mass be equal to m1. Now, as the truck is moving, it is raining. It started raining. So the water gets onto this load. So after some time, you find the mass on the truck has become equal to m2. Whatever the load was there plus the water, the mass has increased. But the truck has to move with a constant velocity u. I am not compromising on the velocity. The truck has to move with the same velocity. Then, whatever the extra force that is required to pull the lorry or the truck is only to compensate for the additional mass. Then, if I write F is equal to dp by dt, this will be equal to m1 into u minus, sorry, m2 into u minus m1 into u divided by t. You observe the velocity remained a constant. When I pull it out, your u will remain a constant. This is m2 minus m1 divided by t. So force will be u into dm by dt. In this case, the mass will remain the velocity will remain a constant, mass will change. Now, let me give an example for this. During the launch of the rocket, so there will be a multi-stage rocket. There are three fuel chambers. As the fuel burns and the exhaust comes out, the mass of the rocket will keep on changing. But the rocket should move with a constant or a uniform velocity. Then you can use this relation. Many a times you would have seen on the Bangalore roads, you have this truck carrying the sand or the garbage. They keep dumping the garbage on the road. Either it is not packed properly or there are some holes. So if the lorry is moving forward, some amount of mass is getting dropped. So the mass will keep on changing. In the same way, in some packaging industry, there may be a belt like this, a belt like this, on which you are going to keep adding the product which has to be moved from this place to this place. As you are adding more and more of the quantity, the mass will keep on increasing, but the velocity of the belt will remain a constant. That force required to keep the belt moving with constant velocity, though an additional mass is there, is nothing but your F equal to U into dm by dt. Now let us have a quick recap of what we have studied so far. We started our discussion with Newton's first law of motion. It states that every body continues to remain in the state of rest or in the state of uniform motion along a straight line until and unless an external force acts on it. This property responsible for that is called as inertia. There are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. The inertia is nothing but a property of a body due to which the body by itself is unable to change the state of rest or motion without the help of an external force. Then we spoke about the force. Force is an external agency which tends to change the state of rest or the state of motion of a body. It is a vector quantity, its SI unit is Newton, it is given by the formula F equal to mass into acceleration. There are two types of forces. One is contact force. In this case, for contact force to act between two bodies, there is a need of physical contact. Non-contact force, though the two bodies are not in physical contact, but still they exert a force on each other. Then we spoke about linear momentum. Linear momentum is also just called as momentum. It is defined as the product of mass and velocity. It is a vector quantity. It is measured in kg meter per second. We spoke about inertia of rest. It is due to the property of mass of a body. Inertia of motion is due to the property of momentum. Any body which has higher mass will have higher inertia of rest. Any body having higher momentum will have higher inertia of motion. Then we spoke about the recoil of the gun and the pushing of the boat back when the person jumps ahead. This is due to the conservation of momentum. Here, the law of conservation of momentum states that when there is no net force acting on the body, on the system of colliding particles, then the total momentum remains conserved. That is, the total momentum before collision will be equal to the total momentum after collision. In the case of the gun, initially the gun was at rest, U1 equal to 0, the bullet was at rest, U2 was equal to 0, so the total initial momentum was equal to 0. But when I fire the bullet starts moving forward with a velocity equal to V2. So in order to compensate for the momentum, the gun will be pushed back with a velocity equal to V1 so that the final momentum M1 V1 plus M2 V2 equal to 0. The initial momentum and the final momentum are equal. If I send M2 V2 to the other side, I will get M1 V1 equal to minus M2 V2. That means the final momentum of the gun will be opposite to the direction of momentum of the bullet. So it will be pushed backwards. This is due to the principle of conservation of linear momentum. Then momentum is a vector quantity. So therefore, when you are adding the momentum either before collision or after collision, you need to take care of the directions. We move on to the next concept. While uh, the cricket player catches the ball and moves his hand through some distance before bringing the ball to a stop. Or why does a pole jump athlete fall on a cushion? It is because when they jump or catch the ball, a large force acts on them for a short interval of time. The impact of this is very, very high. When you slap somebody, when you hit a nail with a hammer, the force acting on it is very large and it is for a short interval of time. This is called as impulse or an impulsive force. It is given by the product of it's given by the change in the momentum of the body, mv minus mu. Then we spoke about Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of a body, that is dp by dt. dp is the change in the momentum, dt is the time. So rate of change of momentum is directly proportional to the external force applied on it, and the change in the momentum takes place in the direction of the force. So force is equal to dp by dt. dp is a vector quantity, so the both of them will be in the same direction. Now we will move on to the last concept for the day. It is called as Newton's third law of motion. I need not have to say the law, you all are familiar with this. For every action, there is an equal and opposite reaction. The Newton's third law of motion states that for every action, there is an equal and opposite reaction. For example, this gentleman is pushing the water back. When the water is pushed back, this will act like the action. The water will give a reaction in the opposite direction. So, whatever force has been applied in this direction, an equal quantity of the force will act towards the left. Suppose I represent this force as F12, the force exerted by the first body on the second body. Then this as F21, force exerted by the second body on the first one. Then according to Newton's third law, I can write F12 vector is equal to minus F21 vector. F12 vector is equal to minus F21 vector. This equal to sign says they are equal in magnitude. The negative sign says they are opposite in direction. The action and reaction pairs are equal and opposite. They will be equal in magnitude but opposite in direction. Let's say when you are walking, this is the floor. On the floor, you exert a force in this direction. This is called as action. Force exerted by you on the floor. Now the floor will give a reaction in the opposite direction. It will be equal to F21. That is why you move forward. F12 is called as the action. F21 is called as the reaction. They are equal and opposite. This is Newton's third law of motion. So this is what I had to discuss in today's session. Let's catch up after 10 minutes in the tutorial session. So I would like to also share an activity for you which you can try it out at home. Today, you can try to call your old friend, not a friend in your school in 10th standard, but a friend maybe a friend in pre-KG, first, second, third standard, whom you are not in contact with now, or call your relative whom you have not met over a long period of time, your ex-neighbor, or your teacher who has taught you long back, or any person whom you have not met or spoken for a long time. Try to take their phone number and talk to them. So, thank you all. Have a great day.